dear audience. I'd like to present today a automated workflow for designing a bridge, specifically a bridge component, a bridge cap. And for that, I have used ontologies and integrated some design rules. Why am I doing this? The bridge design is a very complex task, which engineers have to face. And we have to consider many things while doing that. For example, we have to consider many boundary conditions of the bridge. And so we at our institute, together with some project partners, are doing currently a project that is doing a automated design workflow with integrating this data, which integrates these boundary conditions of bridges, like crossing obstacles like rivers and roads, and then does a hybrid approach for designing the bridge. The project itself is called HybridGen, and then creates a fitting bridge BIM model that can be placed at the specific boundary conditions. And yes, the hybrid bridge generator is composed of several workflows of how to design this bridge. One is a AI-based method that is later presented by my colleague. And I am currently presenting a rule-based method. And, that is tried out on a specific bridge component, bridge cap component here, that is supporting the railing and the traffic barriers and also the foot and cycle railing. There is and this component is highly standardized, and what I was doing in my automated workflow is to assess these boundary conditions I showed beforehand, then align the cap to the bridge and do the dimensioning of this bridge cap. For that, I have created, or we have our institute created an ontology. It's called Bridge Core Ontology, and it's based on several existing ontologies like the Bridge Topology Ontology and the Relative Location Ontology. And yeah, we have created some new classes, adding to existing classes like these boundary conditions I talked about. And within this ontology, I wanted to create some design rules for the bridge cap. And these I get from a German standard that's called BITS-ING. So this is a drawing from this standard. It contains drawings of highly standardized bridge components like the bridge caps. And these include some measurements and also some more information about this component. And yeah, it defines how a bridge cap should look like. And I wanted to integrate these rules that are inherent in these drawings into an ontology, into the ontology that I showed before, and to find automatically the value. And for that, I've used the Semantic Web Rule Language. And here I want to show a small example how to use this. So we have a cap C, and if this cap C has the cap type as the one on the right-hand side in the drawing, then its lower width has a value of 35. That's a rather small and simple rule, but can use more complex rules, and I did that to fully do a automated bridge cap design. And to show you how it's done used in an example, I show the instances that we need to create. For example, we need to create an instance of the bridge and also of the bridge's boundary conditions, the infrastructure routes that are traversing this bridge with their several object properties. Also, we need to create the bridge components like the bridge caps on the left side, the right side, and the traffic barrier and pavement, and all of these components are part of the bridge. And in the end, that's all we need to create before we can run a reasoner that is SWRL capable. And for that, we can, for example, use Pellet, and it does some inferring. For example, it infers that this cap directly left of the pavement. And yeah, also it infers some data properties of this cap, for example, the type, that this cap had no curve, and the value of the lower width that I showed in the slides. And if we then have all the values of this cap created, then we can create such a drawing of the cap, or use it to integrate it into a BIM or IFC modeling workflow that creates a model of this cap. So, in conclusion, I proposed an automated rule-based and ontology-based bridge cap design process that can be extended also to other bridge components, and it does function, and it has some limitations though. For example, the user friendliness. So if we have an engineer, he doesn't often know how to use an ontology or how to create instances. So there's a problem here. Also, this whole workflow that I showed you could be integrated by using object-oriented programming. So that would probably be more efficient, but it has the advantage that we can use the data for example, retrieval augmented generation and integrate it into a bigger workflow that AI methods. And for better user friendliness, we can more intuitive graphical user interface and help the engineer to understand what it is. And with that, I want to conclude my presentation. Thank the two projects that we are working in, and yeah, I'm open